Welcome to the module on securing modern applications. Applications are changing. The way that we create applications is different. The applications that we are creating in the end are different. The technologies we're using to creating the applications are different. Before, when I started as a dev, that was easy times. First of all, there was almost no web apps. There was just HTML, and that was easy to secure because it doesn't do anything. And then we had, an app, a web app, and it would sit on a server and it would go back to the database and it would do stuff and it would go back and then serve it onto the web. And that was it. And even with that, we had enough trouble. But now we have APIs, serverless, and all this other stuff, which means that we have to change the way we do some of our security. So for every single one of these that I'm going to tell you about, the same original rules still apply. You still need to follow secure coding practices. You still need to follow secure design principles. And you still need to, if it is an operating system, you still need to do all the patching and or making sure that the configurations are secure. If it's a network, you still need to follow all the same network security things you would need to do, like identity, etc. So don't throw the baby out with the bathwater and get over enthused. You don't only need to do these things. You must continue to do all of the original secure coding, design, etc. concepts that you have come to learn and love, hopefully, from Alice and Bob Learn Application Security, the textbook for this course. Okay, so this section of this course, you can read way more in-depth information about it in your textbook in Chapter 8. So if you watch these videos and you think, I need more information, go to Chapter 8 and read it and you will be all set. Let's start with zero trust and then assume breach. So way back in the day when we started networks, we had no security because everything was fine. And then it turns out people that had less than honest intentions joined some of our networks and learned about computers, and then we had to start having security on our networks. And the way we started doing that was firewalls. So we would do something often referred to as creating different areas of the network. And so what we would do is we would have a firewall around one area. So let's say we had a public access area, sometimes called PAZ, public access zone. And we'd have all the apps that went out to the public there. And then we would have firewalls all around it. So no one could get anywhere once they got in there. And then we would have another zone. And let's say it would be called the demilitarized zone, the DMZ. We'd have all the very sensitive stuff there. We'd have a data zone, etc. And we'd have firewalls all in between all of these zones. This is often called zoning in network security. You can see why. So you'd have all these different zones, and it was awesome if someone broke in because they couldn't get to the other zones, but it was also awful because they could go everywhere within that zone and just wreak havoc. And so what hackers or red teamers call pivoting, that means going from one computer to another computer, they could continue to pivot all around in the same zone. And if they could find a weakness in the firewall between two zones, they could jump over into that zone. That's very bad. And it turns out that a lot of places, when they show you the network diagram, they would tell you, oh, we have these zones. When I would do pen tests, it turned out they didn't actually have any zones. They had what's called a flat network. And there were actually no zones. There were just things on a diagram, but none of it was actually implemented. This is actually way more common than you might realize. And so a malicious actor, if they can get in that first step, they can just go anywhere in your network, and that's obviously terrifying. And so a new concept came up that was created by a bunch of researchers and then popularized by Google called zero trust. The idea of zero trust is that each server or container or whatever platform is its own island and it trusts no one. So by default, everything is closed. All the ports are closed. Everything's closed. And then you only open something if you need it. This reduces attack surface greatly. So there's 65,000 ports. If you only open one, that means you just need to defend one. And so zero trust means if I have a database, the database should only be contacted by the service account for that application or the database administrator. So if anything else is trying to connect to it, says, no, I don't trust you, I have zero trust. So you can apply zero trust between different applications, between different places in the network. So every single box in your network, server, container, whatever. You can also apply it in the way that you configure things, like locking down all of your ports by default. And even within your applications, you can have parts that are zero trust. I especially expect people to apply this when it comes to your application dealing with any other application or instance. So let's say you have an app and it calls an API, and then that API calls another API. There should be zero trust between the app and the first API, and also between the first API and the second API. And also the second API and the original app should never need to talk to each other, so there should not be trust there. I hope that this makes sense. Again, if you need more details, read in chapter 8. The next thing I want to talk to you about is called assume breach. And you can actually read about these also in chapter 2, where we go over secure concepts. So assume breach means design everything and react as though you may have been compromised. So let's say that you are going to design an app and let's say you have a bug bounty program. Someone submits a bounty to your bug bounty program and it's a critical flaw. And it's for code that is out in production. So assuming breach would mean you would immediately kick off your incident response process to investigate to see if whoever turned in that bounty is not the first person to find this vulnerability. That's very important. And so instead of just protecting the perimeter like we used to do, and then once you were inside, everyone trusted each other, we now no longer trust. And every time something goes wrong, we assume that breach has occurred and we look for it and investigate it. Quite often, when we don't assume breach, that's when we miss really important things. So it might seem like a lot of time to investigate every single critical or high vulnerability that comes into your bug bounty. However, if you have someone living on your network for a year and sharing all of your protected information or your intellectual property with your competitors, that's way more time consuming and definitely significantly more expensive. So assuming breach and zero trust everywhere is a way for you to protect your assets and also ensure that nothing bad has happened and manage to get through your defenses.